Here is the first of your mini screencasts on similarity. Basically, this is just to show you the notation that's used with similarity and what information you can infer when you see a similarity statement. So if I have triangle AQR is similar, that's how you read that symbol, to triangle PMW, what I'm saying is that one of those triangles is either an enlargement or a reduction in the other, but that they have the same shape, just not the same size. The other information you can infer from the way the similarity statement is written is that angle A in the first figure has to be congruent to angle P in the second figure. Angle Q would have the same measure as angle M, and angle R would be congruent to angle W. The other thing you can assume is that AQ, meaning the length of the segment AQ, has to compare to its matching side in the other figure, PM, that this ratio has to be equivalent to, let's say if I pick QR, the way it compares to MW. So it's saying that the corresponding sides have to be in equal proportion. So if you take one side of one of the triangles and you write a comparison or a fraction between that and one side, the matching side of the other triangle, that ratio is going to stay constant no matter which two sides I had chosen to pair up. Let's show this with a figure where I put some links here. So let me put a triangle such as this, and then a triangle that has the same shape but is larger or smaller than the other one. And let's say that this is ABC, and let's say that this is QWP. If I give lengths to A, B, and C to say be 3, 5, and 7, and let's say in my second figure I put down something like 12 right here. And if I further tell you that triangle ABC is similar to triangle QWP, then what I can assume is the ratio of AB to QW would have to be equivalent to BC compared to WP, or AC compared to QP. So let's say that I wanted to know how long this side would be. So I'm using AB and QW. So I would say side AB compares to its corresponding side in the other figure in the same ratio that, now I have to go get the side that matches up with my side with the X. So I take BC, which is 5. It has to compare to whatever value X has in the same ratio that the other comparison had. To solve this, we would cross multiply. 3x is equal to 5 times 12, which is 60. And then dividing by 3 on both sides, we get x is 20. So basically it means if I took this first triangle right here and put it on a photocopy machine and made this side right here grow to 4 times as big, then literally it takes all of the sides and makes each one of them 4 times as big as well. And you can see with this being 20, that is 4 times bigger than the 5. So it doesn't just enlarge one part of the triangle, it enlarges all lengths of all sides. The word for that is that the two triangles, if they're similar, we say their sides, their corresponding sides, are proportional. That is your brief review of similar figures, knowing that the order of the letters matters. It tells you which sides match up with which. And notice BC right here matched up with WP. And it's based on the order of the letters in the similarity statement. I hope you found this small screencast helpful.